My old friend and colleague Colin, who I've twisted his arm, having bragged about his new Hermes too light that I've twisted his arm to come and do a presentation.
77.
77, yes.
So around about the same time.
Yeah. My 50th birthday as an amateur next month. Can't believe it.
Give me the bumps then.
Can't believe it. Well, Terry's longer than me, so there we go. So I'll hand it up to Colin.
Okay, thank you, Mike. Right, this evening, well, firstly I'll ask is, has anybody got a Hermes? Okay, which version have you got? The 2?
Yeah.
Right, she's probably no more than I do then. Come on. Right, what about the Apache Labs Alan series? SDR? Nobody? Okay. Right, well basically, it's a fairly high-level introduction. I'm not going to try and go into all the sort of technical details. If anybody wants to know anything, you can either come and see me afterwards or we can go and play with the radio. So I brought it there and set it up. If there's anything whilst I'm talking, then interrupt me. And ask questions or whatever. So really, I don't actually have a sort of real script other than the slides, so I'm working a bit off the cuff. Anyway, firstly, why did I decide I wanted a Hermes 2 SDR radio? When I got back into amateur radio a few years ago now, SDR was the talk of the latest technology. When I got into amateur radio to begin with, it was all hardware, 3 triple conversion secrets with crystal filters, and then SDR's come along. So I wanted to find out about it. The first thing I did was to actually get a transceiver kit from Chris, NCHF. I don't know if anybody's come across that one. Designed quite a while ago. It works very well. I've still got it, and it's still a good little transceiver, but it does have certain limitations, mainly in the architecture used to keep the price down. It uses effectively a 0 IF, so it mixes down to 0 and samples it with an audio ATD converter. And that inherently means the bandwidth's limited to only about 20 kilohertz, and there's various other limitations. So I wanted something a bit more capable. It had to be completely open source, because I like playing with the hardware and software, so I want to be able to get into it and understand it and play with it. I've got an IC 705, which I use for SSB, so I didn't really need any of the sort of fancy displays. I was quite happy because I'm just going to mainly use it on digital modes to run it on a PC, along with the digital software. I also run QRP, so I only needed 5 watts or so. I do have a Hard Rock 50 amplifier, which is a 50 watt amplifier, so I can run a bit more if I want to. And secondly, well, lastly, it had to be popular, plenty of information on the internet if I get stuck, and still had to be current and being developed. So it really gives me something that I've got a few years to play with. So when I started looking around, they kept coming across the Hermes-Lite. And the more I looked into it, the more I liked it. Basically, the Hermes-Lite, it's low cost, well, compared with a shack in a box of the big 3, it's significantly cheaper. It uses modern SDR techniques, so it's direct up-down conversion, which basically means it samples the whole 0 to 30 kilohertz or 30 megahertz at one time for whatever signal you want. It covers the whole of the HF band, 10 to 160 to 10 meters, 5 watts out. It's actually based on a broadband. Obviously broadband with a number of systems being out there. It makes the chips very cheap and very easy to use. And it's based on Hermes project. So it's a totally open source, hardware and software, including design tools, all design files, anything you could want. And they've all been successfully built. That was a few years ago, so it's well over 500 by now. Right, when I decided to get into it, I was looking around to see what information I could find, and lo and behold, on YouTube there is thousands of videos about Hermes-Lite. This is one particular one I picked. This is an amateur ON7 OFF, I think it is. He's done a whole series of videos about it, and he starts from literally before you even buy the hardware, takes you all through the setup, everything you need, right up to some quite advanced configurations. I've only got to episode 6 of his series, but I think he's got about 12, and he's got a lot of other specialist videos. So you can find anything you need. Right, a little bit of a history on the Hermes. Originally, the Hermes started life in 2011, and it became the Apache Labs Anon 10, I think it was. And then Steve Haenel decided that he was going to produce a low-cost version. So he designed the original Hermes-Lite, which was first sort of produced in around 2014. The good transceiver, it worked well, but there was a few limitations with its design. One of the major ones was that most of the SDR radios contain what they call an FPGA, field programmable gate array, and he decided to use one that was on a little plug-in module. And you bought the board off him, and then you bought the module off eBay or wherever, and you plugged it in. But almost as soon as he released it, the module went obsolete. So virtually, it meant his design was obsolete. So he then decided to do version 2, based on the same concept as version 1. Basically, it tidied up the FPGA side of it, so it brought that on board and came with it. It tied up some of the mechanical arrangements as well, so it made it more compatible with the cases, easier to...
Sorry. Oh, that was my doing. We've lost capture.
Have you?
Yeah, it should come back in a second. I've just replugged. It should.
Yes, good. Right, so yeah, the Hermes-Lite 2 was originally introduced in 2018. So it's been around a few years. I should say quite a few of them have been built. And it's been a very successful. Right, a little bit about the Hermes 2 hardware. I'm not going to go into too much detail, but that's a standard block diagram that's on all the their GitHubs and websites and things. Basically, it's 2 ICs take care of most of the functions. This is the broadband modem chip. It's got an RF front end into front of it. Receive, transmit, switching, bit of filtering. It's also got a direct receive input, but if you do use that one, you've got to be a little bit careful because it's got effectively no filtering. So it can be susceptible to things like broadcast stations. Then the main processing is all done in this FPGA. It's a field programmable gate array. That's an Altura device, quite common, popular, used in all sorts of applications. And that basically takes care of all the I/O, all the real panel, anything. Then you've got a little bit of power supplies. All the connections to it is basically via a 1 gigahertz Ethernet link. And I do recommend that you have a hard-wired 1 gigahertz link. Simply the amount of data it's shoving across to your PC. Otherwise, you'll have problems with dropouts. Right, some of this I've probably already mentioned. Yeah, so based around the broadband chip, with SDRs, the fundamental performance is limited by the A to D converter you've got in it. So the number of bits gives you your dynamic range, and the frequency you're clocking it at gives you your frequency range. So the Hermes-Lite is basically a 12-bit converter clocked at 76 megahertz. So in theory it gives you a 72 dB dynamic range, and it can go up to around a bit over 30 megahertz. In real terms, 72 dB for a typical background noise level is about a S9 plus 10, 20. So it covers most sort of problem is if you've got a strong signal in band and it exceeds that limit, then you'll block the A to D converter, so you lose the sensitivity. It does have a preamp on the front end, so you can adjust the gain, but obviously you lose the weak signals. By comparison, something like the Flex 6700, that's got a 16-bit converter and it's running at 250 odd megahertz. So obviously that gives you an extra 20 odd dB of dynamic range. So whilst you're paying a lot more for it, you do obviously get a better performance, but in all practical terms, unless you're using it for contesting or something, you don't really make use of that extra dynamic range. So for yeah. Well, in practical use, I'd say the Hermes is as good as the 705. Probably if you put it through sort of a Sherwood, whatever review type testing, they could tell the difference. But I've got quite a high background noise level where I am, so I can't really make use of the maximum dynamic range anyway. So it's so in practice, I would say that's good. I mean, probably some of the newer, more modern boxes that have just come out, I mean, they're probably a little bit better. Right, what are they?
Sorry,
Yeah, no problem. Yeah, the Max 10 FPGA, that's what does all the processing. Actually, it's got firmware on it, which configures it for whatever functions you need. It's basically a sea of gates within there. The firmware configures it to implement hardware. It does all the DSP front end of the hardware. So it takes in the full 30 megahertz stream from the AD converter in the broadband chip, and then it actually breaks out up to 4 380 kilohertz wide sections. If you've got software on your PC that can handle that. On some SDRs they call it slices, some call it receivers, but it's basically the same thing. So you can actually have 4 simultaneous receivers running at the same time. They can be on different frequencies across the full 30 megahertz, but obviously you run into problems with the filtering. If you put one on 160 meters and one on 10 meters, the filtering will, one of them won't work basically. Right, the other thing, this was designed back in 2018, or released 2018, but even then it got some of the most advanced options on it. It actually includes all the hardware you need to do, well, I'll call it transmit pre-distortion. Some of them call it pure signal, and Flex radios have had it for a while. See, some of the new boxes from the big three are starting to introduce it. Yeah, the new Icom's got it, and that. I say this is 2018 and they had it. So the others are playing catch up really. And now what that actually does, it monitors the output from your transmitter, and if you've got a linear amplifier, the output from your linear amplifier, and it does a feedback loop to compensate the transmit signal, so it removes any distortion, so you get a cleaner signal. And say the Hermes-Lite's got all that built in already. One thing with the Hermes-Lite, when you buy it, initially you don't put it on the air because it doesn't have any filtering, apart from a little bit just around, but it doesn't actually have good enough filtering to transmit, so you have to buy a filter board to go with it. Other options, there's an I/O board, which is what I've got, which is mounted in the box over there. That gives you basically digital I/O pins you can use to control other things like antenna switches, power amplifiers, whatever. There's also something called a companion board, which is actually done by a different American amateur. And that's really if you're into CW, it provides a direct input to the FPGA chip for your Morse key, microphone and speaker out. So you don't get the latency of it running through the PC. I don't run Morse, but from what I know, people who are good at Morse can actually, the latency is so much through the PC that they just don't like working with it. So that's the sort of options you can get. Right. Now, assuming you decide you want one of these things, next thing is how you go about getting one. Really, so everything is published on the internet, so you can't actually start from scratch build your own. You can get the PCBs made, buy the bits, solder it up. But the designers have tied up with Chinese company Maker Fabs, and they manufacture and distribute direct from China. And that's just a quick snapshot off of their website. This is a couple of days ago. So basically the Hermes-Lite board itself, around $270 odd. Filter board which goes with it, which is designed specifically for the Hermes, so it's directly compatible. Another $50. A case, say 17. And then the I/O board that I've got, another 50. So you're looking at around 300 odd pound to get all the hardware. So the software is free. Just download that off the internet. And in addition to that, you need a PC to run the software side of it. But basically, any reasonable spec PC will run it. Once you get the bits, you need to put them together. And basically, that is a, well, almost assembled version. This is the front of the box that I've got over there. So this is the Hermes-Lite board itself. Filter board, which actually, this is one of these extruded aluminium cases. The boards are designed specifically fit. You slide the board in on the front, filter board in the back. The two boards are then joined together by a little jumper board. And that's literally all your assembly is. There's no soldering, no nothing. In fact, there is one thing missing on that little hole there. There should be a little spacer and a screw going through there. That's where the power amplifier is. That needs to be heat sinked. If you don't, it'll just blow the PA. This one doesn't include the I/O board. The I/O board sits in place of that, and all the connections come at the back. So it basically sits over this area above the filters. If you have the companion board, it goes at the front end. It sits on that connector, and you get a different front panel, but basically everything comes out the front for the companion board. Right, some people take it to the extreme. You can do things like that. Basically, they put a touchscreen PC in the box with the Hermes-Lite, fitted some dials, and got a shack in a box. Which I'm not sure, well, apart from the exercise of doing it, you might as well go and buy a shack in a box if that's what you want. But obviously, it's yeah, it's quite impressive. It's quite a neat little project. But there's all the information about on the internet if you want to go that far. Right. So once you've got your hardware, obviously you need some software to run with it. The hardware itself, so you have to program the FPGA, and the firmware for that you download from your PC. And there's actually two different versions of firmware. If you're running the standard one, which I've got, there's also a separate version which is for the companion board, because that has to map the Morse key and the speaker and microphone to the front panel rather than sending it to the PC. The firmware is basically the same but slightly different. But once you've got the firmware into the hardware, next you're looking at your PC software. The Hermes basically supports Open HB-SDR Protocol 1, which is the Apache Labs original Hermes. That means there's quite a collection of software that's available, which you can use. So you can things like SDR console from Simon. That's quite good with it. Spark SDR, which is the one that people tend to use when they're programming it initially, and then they move on to one of the others. Depending on what you want, hardware you want to write on, you can also get versions for Raspberry Pi, for Linux. The main one, which most people use, is what's called Thetis. And that is basically the software that Apache Labs use with their SDRs. So it's basically the same software. Because it's got the same interface, you can run the same software. See the software itself. Basically, there's a specific version of it which has been done by MI0BOT. He takes the latest version when Apache Labs release it. Because it's open source, he adds in the Hermes-Lite 2 specific parts. There's things like controlling the filter board, that's all built into the software. Whereas things like the Apache Labs don't have that as standard. it's a fork of the standard open Thetis software. So basically anybody can go in, you can look at it, you can understand the code, you can modify it if you want to tweak it yourself. It's very light on the CPU usage. The CPU I've got over there, which is that demonstration, is a little one I just play with. And that's basically an Intel N150 processor, which is equivalent to sort of an i3 fifth generation or something. So it's pretty limited. And on that, it takes about 30% of the processing power. But if you put it on a modern one, my main chat computer is a 12th gen i5, and it only takes about 7% of the processing power. So it gives you plenty left for running any other software you want on it. So you don't have to, you can put any software you like on that PC. I run all my digital mode software on it at the same time. I use the GX Lab suites, but you can run it all on the same with no problem at all. Right, now off the shelf stock, when you run the Thetis software, for the first time you'll get something like that. I tend to run the same, I don't tend to modify it, and that's basically what I've got running over there. It's basically classic SDR type things. It's got everything on it with your pan adapter, your waterfall, bands, modes, filtering, all your noise blankers, adaptive notch filters, multiple notch filters. Loads of filtering is pretty good on it. Then you've got all the various preamps, gains, things like that. But so because it's open source software and people like playing with it, you can put skins on it and color schemes, and basically you can make it do and look anything you like, but underneath the software is the same. So a few days ago, Rob, G3 BBB, you did turn up. I didn't recognize the voice, but I didn't recognize didn't recognize you. Yeah, so he's running mainly for CW. Yeah. So that's actually one of the ones that you sent me. Well, I think I've edited slightly, but basically it's what you sent me. So there, I say he's got his own logos and things on there. You're running the companion board as opposed to the IO board that I've got. But basically, it's exactly the same software, the same functions. The other thing you can notice on there is you've actually got, skim on there. So it's actually putting that information back directly into the Thetis pan adapter. So you can actually see if you're looking for a particular station. And that's all comes with Thetis. Are you running the standard, or you've got an add-on?
This is with SDC,
All right.
a Ukrainian program. So
yeah.
You could feed that screen with spots from the posters, which I do.
Yeah.
And you can also feed it with the live CW, which you can hear. So decode and put the call signs on the top.
Right. Yeah. So it's
You turn up from the skimmer, that's from your receiver rather than from the cluster, is what you're saying.
Yes, the blue ones there are from the skimmer, so that's what it can hear.
Right.
So when it hears a call sign, it will sort of.
Yeah.
When it hears something up from the post, only after it's on the DX cluster, it will put it up on it with a different color. And any new ones that come up, they will flash for a little while just to alert you that they're new.
it's certainly good if you're hunting for particular stations.
Digital mode, or is that just on CW?
No, if you connected it to a DX cluster, it would put up the SSB, and you can set filters on the cluster to what you're interested in. So if you're interested in some, say, posts on SSB, they would come up in the SSB segment.
Yeah. Okay, so that's basically your setup. And some people take it to extremes. Yeah.
In that itself, then, is what you're saying.
No, it's the standard skin. There's hundreds of these skins.
Yeah, you just go on the internet, you can find them and download them. And
It's dreadful ones.
yeah, well, that's what I was. If you want steampunk, and you can actually turn off the the waterfall and the display in the middle. And there's a few people I've seen that have actually done an emulation of the old style radios, the Kenwoods and the whatever. Which I'm not sure they've gone that far, but yeah.
On the previous skin, the logo in the middle, I did change that, so it's got
yeah, so that you've superimposed that logo in there, yeah. But you see, that's basically the same software. Everything else is the same layer. You've got all the same functions on it.
But you can alter everything on there. You can move all the little panels around, you know, you want, and you can have a bigger screen, so you can move it all up the top or all down the bottom.
Yeah, if you want it on a lot bigger screen. I mean, I just run it on a little 15-inch touch screen there, but you put it on a bigger screen, you can get whatever you like. And you meters, you can have analog, digital, whatever. So you can run it on basically anything you like, depending on what software you want to run. Right, so assuming you've got your software, I'm sure some people don't like touchscreens and keyboards and mice. So Thetis, like most SDR software, does support physical hardware. I've got a couple of examples over there interfaced to that. Basically, there's two ways of controlling it. Keyboard shortcuts, which are built in, which is what this Contour Design Shuttle does. That's really designed for graphics software, but it works quite happily with Thetis. But there's a limit to the number of keyboard shortcuts built in, so that is a little bit restricting. And the other main method they recommend is MIDI controllers. And that's the actual one I've got over there. That's a bit over the top, so it's a DJ mixer type desk really. But basically you can map any MIDI command to almost any function in Thetis. There is a few things that they haven't brought out, but most things you can. So I use things like the main wheel for tuning, slider for volume, band change on buttons and things like that. But what's been coming along more recently is some companies have introduced MIDI controllers specifically for the amateur market, for things like the CTR2. Basically that will work with any of the SDR software. It's a standard MIDI, but it's got basically a tuning dial with just a few buttons. So it's much more tailored to the amateur market, shall we say. And like everything else, if you really want, you can roll your own. All you need is a little microcontroller. There's loads of MIDI projects on the internet. A little microcontroller, a few shaft encoders, a few push buttons, and print your own case. You've got your own hardware control for it. So if you decide you don't want a touch screen or software, a keyboard or mouse, so you can use real hardware. Right, what else have I? Oh, right. Once you've got this system running, you want to connect it to other software, things like digital modes, logging, whatever. Basically, it's like any other rig. The main difference is it's software running inside the PC. So rather than having a physical audio cable and a physical cat cable from your chap in your box, everything links together via virtual cables. It's just a little piece of software you run. It's a little bit of fun configuring them, but you've got to basically map the audio output from Thetis to the audio input of WSJT, and then another audio channel back the other way. And then for control, basically you can use virtual serial ports, which does a cat control. And that works very well. So I use FOBG, WSJT, no problems. It'll link to all your logging software, so no problem with that. But the other thing it does support is TCI, Transceiver Control Interface. That's a new standard which is coming mainly through, I think it was Expert originally did it on their SDRs, but a lot of the amateur software adopted it. So rather than having to have audio cables and USB and all the rest of it, but basically it's a network connection. You just establish a network connection between the two bits of software and everything goes across the network. It's much easier, there's no configuration. And that's, yeah, a lot of them are beginning to bring it in. I think eventually the big three will have to put it into their radios. It seems to become a standard. Yeah, there is other ways of doing a network connection that various companies have got, but really TCI is the standard that most seem to be converging on. And then, well, we've already talked about it, but I've never tried it, but say SDR skimmer and the clusters, no problem, directly connect to it. But basically anything you can do with any other radio, you can do with betas and the Hermes-Lite. Right, lastly, my experience with it so far. I've had it about 6 months, but then I'm not playing with it every day. So I'm definitely still learning. I wouldn't claim to be an expert. There's far more advanced experts. Whenever I get stuck, you just go on YouTube, the internet. There's loads of. You can basically search for any problem you've ever had with it. And so far, it's been really good. I'm really pleased with it. For basically a 300 quid piece of hardware, it is as good as £1,000. But you know, obviously, you've got to have a PC, and you've got to support the PC. So it's not a shack in the box. It's not going to be for everybody. Then if you want something just switch on and natter, then you know, buy a standard radio. But if you want something to play with and something to spend a bit of effort into actually getting into it and using it, it's definitely worth the go. And I think I recommend anybody to have a go at it if you want to have a go. Right. Well, that's really all I wanted to cover. So, you know, any other questions, anybody? Or anything that anybody else would like me to go into any more detail? Yeah. Yeah.
Four stations, was it?
For the hardware, for the Hermes-Lite itself, can support up to 4 receivers, or some SDRs call them slices, but basically it's 4 chunks of the spectrum. So the modern SDRs, they sample the whole from 0 to 30 megahertz continuously. And you just select the piece that you want to look at.
I suppose you want to get it on, say, 40 metres, you want the list of the 4 frequencies. Will you do that?
Yeah. Within the 40 metre band, that's fine.
Yeah.
Well, with any band, yeah. The only slight limitation is if you want put one at, say, 160 metres and one at, say, 30 metres, or 10 metres or something. Yeah, especially if you've got that filter board fitted, then obviously that will filter out. Yeah. But apart from that, the hardware will support it. Obviously, you need software on your PC that will support multiple receivers.
So how many slices can you flex with? Depends how much you want to pay.
Yeah. It's, yeah, I think some of them got even more than that.
If I put it at 10 meg bandwidth, then I can go from 14 meg to 24 meg. If you wanted to, say, look at FT8 for each one of those parts, you can just put a different receiver on each one.
Yeah.
You have to feed them to decoders.
Mm. Things like SDR console and that can do that. Yeah. I'm not sure about Cetus whether it will support more or not. I haven't actually tried that. But,
so we get 4 audio channels from each one, and then you decode all.
Well,
you set up 4 virtual audio channels.
Right, and then double the routing, like you were saying.
Now
Yeah.
you can have 4 different WSJs.
Mm.
So is the filter is it switchable bandwise or?
Yeah, and it's automatically controlled by the hardware. So depending on which band you select, it'll automatically select the filtering to suit.
And that limit then just what individual receivers you can.
Yeah, basically you've got to have the receivers within that filter. I mean, you can use a direct receiver input, but obviously the risk with that is if you've got, say, a big broadcast station right alongside you, you'll overload the HD converter. But other than that, it's no problem. But yeah.
It'd be nice if you had multiple filter boards, stack them up, wouldn't it?
But you'd have to have multiple inputs then somehow. But apart from that, yeah, it would be good. I'm sure somebody could do it. That's one of the advantages of being open source. You can do what you like. All the circuits are published, all the software is published. If you want to.
Install the latest software, you just press one button and it configures it for that filter
Yeah, if you use the right filter board, it'll just automatically configure it all. I mean, you can go in and configure it yourself if you want to change it, or if you're using some other filter board. So it's pretty flexible, it can do almost anything.
So the filter board is just generally accepting the band rather than deciding whether it's SSB or CW or...
Yeah, once you're within the band, then everything is done in software.
It's done digitally.
Yeah, so the SDR does all the filtering. And all the things like the notch filters and all that sort of stuff is all implemented in software. So it's,
Noise reduction.
yeah, that's all. Everything is software. Once it has been sampled, that's where all the clever stuff is. And the hardware is relatively simple these days. It's the software. Yeah. Okay.
No, well, thank you, Colin. I
Okay.
put you on the spot by
Well-
nominating you to do it.
Thank you, that's really interesting.
Well, it's only a high-level introduction, so you can go a lot more depth if you want. But say there's lots of stuff on the internet. If you're interested.
There, I'm going to have a
Yeah,
look.
he's probably fallen asleep on that. But
Yeah, thank you very much.